Hello and welcome. My name is HFB1022 and I'm from Group 10. This presentation is for the subject Scientific Inquiry. The article I will be presenting is titled Innovation Research of Smart Grid Technology in Electrical Engineering by Cheng Jia Bao. And this is the team member. This study explores the rapid advancement and application of smart grid technologies in electrical engineering, focusing in demand-side management, automated distribution, and renewable energy integration. Smart grids are shown to improve energy efficiency, reliability, and real-time user interaction. The research highlights emerging innovations such as IoT, AI, and big data analytics, while also addressing future priorities like cybersecurity, standardization, and cross-industry collaboration.
Introduction. The energy sector is facing major transformation due to increasing global electricity demand and growing sustainability concerns. Traditional power grids are struggling to meet modern requirements, leading to inefficiencies, energy losses, and limited monitoring capabilities. In this context, smart grid technology meets these struggles, offering a promising path forward in electrical engineering. Background. Smart grids incorporate advanced technologies such as automation, artificial intelligence, big data analytics, and Internet of Things. These technologies enable real-time monitoring, predictive maintenance, and improve system performance. By optimizing energy generation, distribution, and consumption, smart grids offer a smarter, more reliable, and environmentally responsible alternative to conventional grids. Research questions. 1. How do smart grids enhance power system stability, efficiency, and automation? 2. What innovations improve power distribution and management? 3. What challenges hinder the widespread adoption of smart grids? 4. How do AI and big data and Internet of Things impact performance and reliability? 5. What roles do standardization, cross-industry integration, and cybersecurity play? Hypotheses. 1. Smart grids improve system efficiency and reduce energy losses. 2. AI and big data enhance forecasting and resource optimization. 3. Microgrids increase resilience in outage-prone areas. 4. Internet of Things supports real-time monitoring and system maintenance. 5. Cybersecurity and privacy are major barriers requiring strong safeguards.
This section examines the methods and materials used in the article. The study employs a descriptive approach relying on a review of existing literature and technological advancements rather than conducting original empirical research. While this approach offers a broad perspective on smart grid innovations, it lacks a structured research framework incorporating qualitative or quantitative methodologies, which are essential for validating claims with empirical evidence. A key limitation is the absence of empirical data, as the study does not include experimental, correlational, or survey-based research. Additionally, the lack of specified primary resources or datasets makes it difficult to assess the reliability and validity of the information. A more rigorous mixed method approach, integrating statistical analysis and expert interviews, would have enhanced the study's credibility and analytical depth. For the author's conclusion, Cheng Bao's article provides a comprehensive overview of smart grid technology, emphasizing its role in enhancing power system stability, efficiency, and sustainability. The author explores key innovations including big data analytics, artificial intelligence, microgrid technology, and IoT, highlighting their impact on electrical engineering. However, the article lacks an in-depth discussion of cybersecurity risk, infrastructure cost, and regulatory barriers, as well as social and economic factors influencing adoption. Despite these gaps, it serves as a valuable resource illustrating the transformative potential of smart grids and emphasizing the need for continued innovation and collaboration in the field.
In conclusion, the study reveals that smart grid technology is reshaping the way we generate, distribute, and consume energy. One of the biggest advantages is its ability to reduce waste and improve efficiency. By incorporating automation, artificial intelligence, and big data analytics, smart grids can predict demand, optimize power distribution, and minimize energy losses, making the entire system more reliable and cost-effective. Another key finding is the enhanced reliability and resilience that smart grids offer. Unlike traditional grids, which are prone to blackouts and inefficiencies, smart grids use real-time monitoring and automatic fault detection to identify and resolve issues before they cause major disruptions. This is especially important in regions where power outages are frequent. Additionally, the integration of microgrids strengthens the overall system by allowing smaller, localized power networks to function independently when needed.
So for the first point, which is the higher upfront cost, where in this part it was stated that the limitation of this smart grid is actually the initial financial investment, where normally it's require a high amount of money to be implemented in a country. So basically, what is the suggestion to help in overcome the challenges is that to implement subsidies and also provide more engage with more investor from outside of the country to invest in the smart grid technology in developing country especially. While for the second point, which is the interoperability issues, where the limitation is actually about there is no standard protocol for smart grid to be implemented in a lifetime situation, especially in nowadays. So the suggestion is to establish a platforms or universal standard to allow the scientists or the engineers to exchange data and communicate between them. While for the second point, which is the interoperability issues, where the limitation is actually about there is no standard protocol for smart grid to be implemented in a lifetime situation, especially in nowadays. So the suggestion is to establish a platforms or universal standard to allow the scientists or the engineers to exchange data and communicate between them. For the fourth point, which is the cybersecurity vulnerability, the limitation of smart grids prone to cyber attack, posing threats to energy security. So what means that is basically it's provide a higher risk of cybersecurity to be exposed for the users or the consumers. So the suggestion is to implement instructions detections and prevention systems on the smart grid, where we require many more computer engineers to improvise or to improve the system time by time. For the fifth point, which is the regulatory barrier, where this means that there are slow policy adaptations in the society for moving toward the smart grid technologies. So what should be done is that the government should actually introduce a supportive regulations, such as doing more campaign to realize the investors or the company to move to smart grids time by times, so that the Malaysian country can be improvised or run through the smart grid in the futures. The final point is that the resistance to change, where this happen in the company that have not improvised or not using smart grid in their technologies. So due to they don't understand how these things work, so they don't want to change to smart grid. So what we can do is that by conducting awareness campaign to help them to know what is smart grid in the futures, they would like to implement it so that they can help and do a better job. The final point is that the resistance to change in their futures and more efficient for the company to be done. So that's all from me. Thank you.
Next, critical elements. In the positive side, the article provides a strong overview of smart grid technology, clearly explaining essential components such as demand-side management, automated distribution, and integration of renewable energy sources. It also introduces modern innovations that offers insight into their roles in improving energy efficiency and grid intelligence. The discussion of practical applications adds value by demonstrating how these technologies function in real-world settings. However, this study has several weaknesses. It lacks technical analysis supporting datasets and case studies, which limits the credibility of its claim. There is also no empirical evidence to validate the theoretical benefits presented. Additionally, the research is mainly focused on China, particularly Gansu province. without offering comparisons to other regions or addressing how these technologies could be applied in low-income or rural areas. In conclusion, the article presents smart grid technology as a vital innovation in the future of electrical engineering. By emphasizing sustainability, automation, and intelligent energy management, the study highlights how technologies like AI, IoT, and big data can modernize power systems. The study effectively captures the potential of smart grids to transform how we produce, distribute, and consume electricity. Yet, to fully realize this potential, future research should move beyond conceptual discussions and include data-driven analysis, diverse case studies, and global comparisons. Broader perspectives will help to validate these technologies in different regions and economic contexts. Overall, the article is a strong starting point that opens the door for deeper exploration and practical advancement in the smart grid field.